Welcome to the our video presentation for Technical English 1. Today, I will present a comparative study of the three important materials: ACE, epoxy resin, and hard carbon steel. In this video, we analyze and compare three properties and three common applications. Furthermore, we explain how one application contributed to the sustained development goals of the 2030.
ABS is a popular thermoplastic polymer. This material has excellent mechanical properties, which shows incredible impact resistance and high rigidity. Therefore, it does not break easily when it falls. It has also high versatility, chemical resistance, and electrical insulation. However, it has a low melting point and poor environmental resistance, so it's not suitable for high temperatures. ABS is usually used in the manufacturing industry as it's perfect for durable consumer goods, plastic electronic housings, and automotive interior parts because it is cheaper and lighter than metal. Epoxy resin is a thermosetting polymer that is initially liquid. It hardens with a catalyst, forming a strong and durable material. It is characterized by its high resistance to environmental factors such as humidity, chemicals, and temperatures ranging from 10 Celsius degrees up to 180 Celsius degrees. It is primarily used to create protective coatings for surfaces in adverse conditions, and also as a lightweight material in industries requiring high strength and low weight. High carbon steel. It is an iron-based alloy composed of carbon 0.6 to 1% and manganese 0.3 to 0.9%. High carbon steel is the hardest material of our selection, but is the least flexible. It possesses outstanding wear resistance, and it retains a sharp edge perfectly. It is used in the manufacture of cutting tools, elastic elements, discs, and kitchen utensils. In addition, it can be hardened through quenching. It's moderate conductor of electricity, and it withstands temperatures of up to 420 Celsius degrees. However, perhaps its weakest point is its low resistance to corrosion.
Let's compare these materials deeply. First, we must look at strength and weight. High carbon steel is significantly heavier and denser than ABS and epoxy resin. It offers the highest tensile strength, which means it can withstand massive loads. However, ABS is much lighter than steel. For applications that need low weight like cars or drones, ABS and epoxy composites are better choices than heavy metal alloys. Second, we can analyze how they behave under stress. High carbon steel is the hardest material here, but is the most brittle. It doesn't bend easily, and it snaps under extreme force. In contrast, ABS is more flexible and resilient than steel and epoxy. When ABS receives an impact, it absorbs energy efficiently without structural failure. Epoxy is rigid, but it requires a structural matrix to resist impact. Third, let's look at environmental resistance. High carbon steel tolerates much higher temperatures than the two polymers. EBS melts quickly at around 200 degrees Celsius, and epoxy degrades if the heat is too intense. Nevertheless, epoxy resin is the most efficient material for chemical protection. It resists water, acids, and corrosion perfectly. Steel is the worst material in wet environments because it oxidizes and rusts rapidly. Finally, we compare their processing. ABS is the easiest material to recycle because it is a thermoplastic. You can melt and reshape it repeatedly. In contrast, epoxy is impossible to remelt after the chemical reaction. Steel requires extreme industrial heat to melt, but it can be transformed into a new component successfully.
This design is strongly linked to the SDG 9: industry, innovation, and infrastructure. The evaluation of the materials such as ACE, epoxy design, and high-carbon steel demonstrates the fundamental importance of the material selection in the modern industrial development. Each material contributed to innovation in different ways. ACE facilitated the manufacture of lightweight and formal parts, enabling mass production and technology acceleration. Epoxy design facilitated the creation of the high-performance quantities and composite structures. It provides durability and toughness under hard conditions. High-carbon steel membrane provides strength and durability to tools and industry machinery. By analyzing and selecting the right materials for specific applications, industry can improve efficiency, reduce costs, and extend the product lifespan. This contributed to more sustainable industrialization and support the development of the strong infrastructure goals and clearly aligned with SDG 9. Conclusion. To conclude, understanding the material properties helps engineering choose the correct option for every project. Ace, epoxy design, and hard-carbon steel play different roles in the modern technology and manufacture. Thank you very much for your attention.